Hello, calculus people. I want to talk to you a little bit about the quiz that you're going to be doing next couple of days. It is the one involving volumes of known cross sections and volumes of revolution. So I wanted to show you some things that might help you in doing this quiz. So if you'll bear with me for a few minutes, we'll work a couple of problems. The first one I'm going to do is in your textbook. So if you'll go to your textbook. Okay, Theo, it's on page 264. Oh, my bad, Theo, it's not on page 264. Hang on a second. It's in section 2, chapter 6. I was in section 2 of chapter 5. Look at question number 8, section 2, chapter 6. That can be found on page 373, looking at question 8. We have the base of our solid as the unit circle, I believe. Is that accurate? When I read that, it says that the base, let B be the solid whose base is the unit circle. So write the equation of the unit circle. X squared plus y squared equals 1. Got it? That's the base. And the vertical cross sections are perpendicular to the x-axis. So if I draw me this, x, y, I draw the unit circle. That's my picture. Okay, this is the equation. X squared plus y squared equals to 1. My vertical cross sections are perpendicular to the x-axis right here. Okay, now my solid is made by making these an equilateral triangle. So the equilateral triangle is coming up out of the page to make this a three-dimensional solid. Okay, the base of it is a circle, and then the cross sections are an equilateral triangle. All right, we are told that the area for a, wait, no, we're not. It says to show that the vertical cross sections have area square root of 3, 1 minus x squared. Okay, let me show you that. It's not complicated. All right, first of all, if you've got an equilateral triangle, that means that this, and this are equal, right? This is 60 degrees, this is 60 degrees, and this is 60 degrees. All right, and then I draw my altitude there. How do you find the base? I mean, how do you find the area of a triangle? It's 1/2 base. This is S, this is S, this is S. Now, what would the height of this be right here? Anybody know? You can find it, right? Because the sine of 60 degrees equals to H over S. Anybody offhand know what the sine of 60 degrees is? If you don't know, plug it in your handy dandy calculator. Square root of 3 over 2. Okay. So H then, in terms of S, would be 1/2. Oh, excuse me. Square root of 3 over 2. S. To find the area of our equilateral triangle, then it's 1/2 the base, which is S, times the height, which is the square root of 3 over 2 S. So the area of any So the area of any equilateral triangle is square root of 3 over 4 s squared. All right, that is the area of any equilateral triangle. Now, let's talk about our particular problem. We've got the base of this triangle right here. How do I get that in terms of x? Well, first of all, I'm going to solve this for y. I get y equals to the square root of 1 minus x squared. That's this distance right here. This distance is equal to the y coordinate. So what is this distance from here to here? It's 2 times this. So the length of my base is 2 times 1 minus the square root of x squared. Okay, and I believe that's what my side length is for my s. S is that. That's the length of each side of my equilateral triangle. Okay. Now, if I use that and plug it into that, I will get the area of each of my triangles. So it's the square root of 3 over 4 square root of 3 over 4 times 2 1 minus x squared squared, which gives me, when I simplify this, square root of 3 times 1 minus x squared. That is the area of each of my triangles. Now to find the volume, I'm integrating this from -1 to 1. Square root of 3, 1 minus x squared dx. That is my integral. So to calculate the volume, you can do all this math. You can actually do this on your calculator as well. That's what we would get, and that would be in cubic units. So when you are finding the volumes, first find the area, okay? First find the area of the cross section. Now, the areas of the cross section are going to be probably one of 3 things. It's either going to be a square, it's either going to be a triangle, or it's going to be a semicircle. I have yet to see any other type of cross-section area on anything that I've looked at as far as an AP test is concerned. You should know how to find the area of a triangle. You should know how to find the area of a square, and you should be able to find the area of a semicircle. Now, let's go back up to this problem just a second. What if we were told that this was the base of this was the unit circle, and we were told that our cross sections were squared, or squares, I should say? Well, how would that make this problem different? It would make this problem different in this way. Okay, you ready? This is how it would make it different. To find the area of a square, you take the length of this side, which is S, right here, and then you would just square this, and it would be 4, and my final answer would be 4. Instead of this right here, it would be 4, 1 minus x squared. That's the difference. What if we were told that the cross-sectional areas were semicircles? Because that's something that you see a lot. Cross-sectional areas are semicircles. Well, if this is a semicircle, how would that change this right here? Well, how do you find the area of a semicircle? You do 1/2 pi times the radius squared. And now this would be the radius. So we wouldn't use this. Our radius would be r equals this. So it would be 1/2 pi times this squared. And that would go here, and then that thus would go here. Okay, so that's how you find the volume using known cross sections. All right, the next part of the quiz is going to be the average value function. Average value function is quite simple to use. The average value of a function, I'll just write it out here, is 1 over b minus a to b of some function. We just use that equation to find the average value. These types of problems were on page 375, and I'll look at, say, question number 42 on page 375. All right, we're finding the average value of the function secant squared and we're going from pi over 6 to pi over 3. I'll do 1 over b minus a that yields the following. We need to subtract pi over 6, pi over 3. So if I subtract pi over 6 from pi over 3, I get pi over 3, and 1 over pi over 3 is 3 over pi, right? So this now becomes 3 over pi times the integral no, it doesn't. It becomes 6 over pi. I'm such a boo-boo head. 6 over pi times the integral of secant squared from pi over 6 to pi over 3. The antiderivative of secant, I need my dx in there. The antiderivative of secant squared is tan, right? So 6 over pi times the tangent, sorry about that, of x evaluated at pi over 3 and pi over 6. Okay? You can actually do actually do this on your calculator and put it in decimal form, or if you want to be really impressive, you can put it in exact form. If you do it exactly, you would get 4 over pi times the square root of 3, or 4 square root of 3 over pi. When you write your answers in decimal form, please put it to 4 places. All right, volumes of rotation. There's going to be a couple of different types. All right, you're going to revolve it either around the x-axis, y-axis, or you're going to revolve it around a vertical or horizontal line. I have yet to ever see any of these volumes of rotations on anything other than a vertical or horizontal line. I have never seen one where they do it over an oblique line. I imagine you could, but I've never seen it. All right, let's look at an example. Let's say we want to find the volume